That'd be a good idea. So we want to know if each set is closed under the operation of addition, and and we learned about, or we talked about this yesterday. If the answer is no, that's when we have to do the work. Yes is just a simple yes. All right, and that's kind of dangerous though, because if you go yes when you're supposed to go no, then you may not even realize that you're showing not even remotely the amount of work that you're supposed to show. But that's kind of the point. All right, so the set of odd integers, would that be open? Well, open, closed or not closed under addition? What do we say there? Not closed. All right, so if I add any two odd numbers, it's possible that I get something other than an odd number. All right, so give me the counter example. The classic. All right, rational numbers. If I add any two rational numbers, will I get a rational number? Yeah. Yeah. Multiples of 3. Any two multiples of 3, do I get a multiple of 3?
Yes.
Yeah. So here comes the prime numbers. First, we'll start off with, what is a prime number?
A number that can only be divided by 1 in itself.
A number that can only be divided by 1 in itself. All right, so I'll make a note of that so we have it. I'll say only divisible by 1 or itself. All right, with a little condition there that it has to be greater than 1. All right, because a common misconception is that 1 is a prime number, and that's not true. All right, so 1 is not a prime number. You might say, well, 1 is only divisible by 1 in itself, but this is a working definition of the term prime number, only divisible by 1 in itself. It's one that people, they use because it kind of tells you how to find a prime number. But the true definition of a prime number is a number that is divisible by exactly 2 unique values. All right, so it has to be divisible by exactly 2 unique values. All right, in that case, it would be 1 and itself. All right, if you're looking at the number 1, it's not divisible by 2 unique values. It's divisible by 1 value itself. All right, unless you start incorporating negatives and fractions and things like that, which is out of bounds when we talk about prime numbers. All right, so if I add 2 prime numbers, well, we'll take a couple of simple prime numbers like 2. I'm going to go blue for those keeping score at home. And what's the next prime number up? 5. Well, 3, but really any pair is going to be fine. So 2 plus 5 is 7. Right? Prime, right? That works? All right, let's grab another prime. How about, let's do 2 and 7. We get a 9 there. Is 9 a prime number? No. What numbers divide evenly into 9? Just shout them out if you know.
3.
Yeah, among other things, but 3 is the one that screws everything up. So we're saying no, and because of that. So I don't know, for better or for worse, this is the way I do things. Raising hands is, I'm sure there's a place for it. I never notice when people are raising their hands, or I try to notice, but it doesn't always work out. And I'd hate for somebody to patiently be waiting to get called on, and I just never get around to them. If you know, just say it. All right? Don't be shy. All right? It's better for me that way. I just like the conversation to keep moving. I want class to be more like a conversation. rather, imagine the conversation playing out that way. If you're talking to a group of people, and every time you say something, and a person wants to reply, they raise their hand, wait to be called on, and then they contribute to the conversation. It would go nowhere. Fun. I don't know. All right, irrational numbers. If I add any two irrational numbers, will I get an irrational number as a result? Yeah. All right, that's something like pi plus 1. You know, pi is irrational. Add a 1 to it. You put it in your calculator, you're going to get a nasty decimal that doesn't repeat, never ends. Same quality of nastiness as pi itself. Negative numbers. If I add two negative numbers, do I always get a negative number? What we say? Yeah. It's just going to get more negative, right? Now, if you subtract, different story, because then the two negatives might offset, become positive, and go from there. Now we're switching over to multiplication. Is each set closed under multiplication? So even times even, is it even? Yeah. Yes. Odd times odd, is it odd? Yeah. We're saying yes. All right, so if at any point you come up with a counterexample, it becomes a no. But, just test a few. So, simple one like 1 times 1. Negative 5 times negative 3. 7 times 7, all odd results. All right, irrational numbers. Irrational times irrational. All we need is one counterexample. What do we say there? If I multiply two irrational numbers, could I possibly get a rational number? You got a 50-50 shot. Nobody's going to judge you if you guess wrong. Yes. We say yes. I say... And I totally just judged you. Yeah, you totally got it wrong, and it was so humiliating. No, nobody cares. All right, radical 7 is irrational. If I multiply two irrational numbers that are identical by each other, then it becomes rational. All right, so there's my counterexample. It starts getting a little fishy when you get into things like pi times pi, which we write as pi squared. But the only reason we write it that way is because we don't know what pi is exactly. So we can't really say what the result would be, because otherwise we wouldn't have a number pi. If I knew that pi squared was, let's say, 71, then we wouldn't have a pi symbol. It would just be the square root of 71. So it's not necessary. Also, there's different flavors of irrational numbers. Maybe it's like a cube root or a seventh root or something like that. It doesn't have to be necessarily a square root. But remember, all we're looking for is a single counterexample. One situation that shows us that it's basically not. All right, negative integers multiplied, what do we say? If I multiply two negatives, will I get a negative? No. So negative 2 times negative 3 equals positive 6. Now, whole numbers. Whole numbers, that's 0 and up. No decimals, no fractions. All right, no negatives. All right, so we want to know, is it closed under multiplication? If I multiply two whole numbers, will I get a whole number? Yeah. If I divide two whole numbers, will I get a whole number? No. Not necessarily. So, counterexample would be what?
1 divided by 2.
It sure would. So, the set of 0, is it closed under addition? Yes. 0 plus 0 is 0, right? What about subtraction? Also a yes. Multiplication? Yep or do. And division? No. And that's because 0 over 0 is what we call indeterminate.
Did you get your new iPad yet?
I did.
Wow.
You really sold that. It was great. Such a powerful moment. Sorry, I'm gonna stream close up. Whoa. All right, I was stealing space from 14. Now it looks terrible, but it is what it is. It is what it is, as Mr. McCallie would say. All right, so let's actually just run through it before I start writing anything. The set of 1, closed under addition?
No.
Why?
1
plus 1 and 2. Subtraction? No. Multiplication? Yes. Division? Yes. All right, so addition, subtraction is no. Multiplication, division is yes. All right, and they weren't asking for counter examples. I just wanted to touch on the 0 over 0 because it's technically considered to be indeterminate, but people tend to want to write undefined, even though that's not technically correct. All right, the number 10, closed under addition?
No.
Subtraction?
No.
Multiplication?
No.
Division? No. So I'm not going to itemize, I'm just going to say no. 0 and 1, addition? Subtraction? Multiplication? Yes. Division?
No.
So multiplication, yes. Addition, subtraction, division, no. All right. So again, remember, you can repeat values. So the 1 plus 1 would give you 2. And something like 0 minus 1 would give you a negative 1. Division, anytime there's a 0 in the set, division isn't going to bear out as a closed set because it's always going to include something that's either undefined or indeterminate. All right. 1, 3, and 5. Addition? No. Subtraction? No. Multiplication? No. Division? No. So no. Irrational numbers. Well, we've already addressed multiplication, right? So we know that that's going to be a no. I think we also addressed addition. We got yes for addition. So subtraction would kind of go hand in hand with that. If I subtract 2 irrational numbers, in theory I would get irrational, but there is the one counterexample, so we'll address that in a second. Let me just zoom in here. So addition, I'm going to itemize this one, subtraction, multiplication, division. So I know if I add 2 irrational numbers, or an irrational number with anything else, it's going to be irrational, so that's a yes. Subtraction, we can say no. What would my counterexample be?
1 of the irrational numbers minus the same one.
Exactly. One of the irrational numbers minus the same one. So anything you want. I used radical 7 before, so I'll do that again. Radical 7 minus radical 7 equals 0. 0 is a rational number. All right. Multiplication, we said yes, because if you do the product of 2 identical irrational numbers, it becomes rational. Division. Oh, wait. So I don't know why I wrote yes. That was weird. I'll write the counterexample. Division is also no. Why do we say no for division? Exactly. That's what I was thinking. I agree wholeheartedly. But, say it out loud this time instead of using telepathy. So everybody else can hear it. Radical 7 divided by what? Divided by radical 7 equals 1. Right? Not irrational. Even integers. If I add two evens, will it be even? Yes. All right. Subtract two evens, is it even? Yes. So addition, subtraction are both yes. Multiply? Yes. Divide? No. So these are all yes. Division is a big old no. Odd integers. Add two odds. What do we say? I mean, we addressed it before, but we say no. Subtract two odds. 1 minus 1. Is it odd? No. Multiply two odds. Well, I mean, it's all addressed on the previous page, right?
Yes.
Yeah, that's a yes. And dividing two odds. If I divide two odds, will it be odd? No. So addition and subtraction are no's. Multiplication and division. Wait, what did I say? No? I meant to say yes. I meant to say the opposite of what I said. Yeah, if you divide two odds, the result. Oh, sorry. It's still a no. It's a fraction. Space Cadet. Trying to walk and chew gum at the same time here. Division. These are all no's. The multiplication was the only yes, right? All right.